Hello students, here we are again to study the chapter Motion and Time. As you all know that this is the fourth lecture. In the previous lecture we have finished most of the things from the chapter. We have discussed the things related to this chapter. In this chapter we are just we are going to start what is the time distance graph, how can we plot time distance graph, and then different types of the distance time graph, and then we have to just solve some problems based on distance time graph. So let's start. First of all, what is distance time graph? Distance time graph is just a simple line graph that denotes the distance versus time finding on the graph, or you can say that it is just a graphical representation between the time and distance, or you can say that it is the graphical representation between the relationship of time and distance. When we plot a graph which is showing the relationship between distance and time is known as distance time graph. Okay, when we plot the distance time graph, we always show distance on y axis and time on x axis. As you all know that the graph contains the two axes. One we used to say x axis and other one is y axis. So on y axis we always used to show distance, and on x axis we used to show time. Now the next thing is that how can we plot distance time graph? First of all, here I have just noted some points on which we can make a distance time graph. First of all, you have to just make the axis. Suppose we have taken a graph. All of you have seen the graph. It contains the verticals and horizontals lying and making the square like this. If you have seen the graph, clear? So first of all, you have to make the axis. As I have told you that there is two axes, you have to make y and x axis. Okay, this is the x axis and this is x axis and this is y axis. Now choose the scale for time and distance. As you all know that on y axis we used to show distance and on x axis we used to show time. So what you have to do next, we have just made the axis x and y, and on x we have denoted time and on y we have denoted distance. Clear? Now you have to choose the scale for time and distance. So the next step, what we used to say, we will write here 1 centimeter on scale is equal to 1 kilometer, and 1 centimeter on scale is equal to 1 hour. This scale you have to choose. Otherwise you can also choose 1 centimeter is equal to 1 meter, or 1 centimeter is equal to 1 second. But don't forget to write here on y axis 1 centimeter is equal to 1 kilometer, and on x axis 1 centimeter is equal to 1 hour. Clear? Now we have just chosen the scale for time and distance. Now the next thing is that mark the value. Okay, you have to just mark the value of which it is given in the question. Suppose that it is given in the question that 5 kilometer a vehicle travels 5 kilometer in 3 hours. Clear? So here time is also given and distance is also given. First of all, you have to just mark the value. It is always started from 0. Then you can write here 1, 2, 3, 4, 5 and 6. In the same way 1, 2, 3, 4, 5. Now you have just marked the scale. Now what you have to do, you have to just mark the value. Distance is given here 5 kilometer. Where is 5? We have to just find out the 5, and then time is given 3. 1, 2, 3 means if we are going through this, here will be the value. Okay, now we have marked the value because it is the 5 kilometer and time is 3 hour. So we have just marked the value. Now draw a parallel line to each. We are going to draw a parallel line on x axis as well as on y axis, then we get automatically we get the value. Now the fourth one is mark the point of intersection. Suppose that in graph you are getting the questions. Here I have just made the graph. Zero, 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. As you know that this is time and this is distance, this is y axis, x axis, and this is y axis and this is x axis. First of all, I had told you, suppose that two values are given here. The first one is a vehicle travels 5 kilometer in 5 hours and then it travels 3 kilometer in 3 hours. Clear? So you have to just mark the value 5 kilometer in 5 hours, it will be the value here. So just put a dot here. Now 3 kilometer, it is the time distance, so 3 kilometer, just find 3 kilometer in 3 hours. The value will be here. You have just make the parallel line to finding the exact value. Now you got two points of intersection. Okay, now what you have to do, draw a parallel line to the values that we have done. Now the next point is mark a point of intersection. As we have marked the point of intersection, one intersection and another intersection. Now you have to join the intersection with a line. Join this intersection with a line. In this way you are getting a distance time graph. In this way we are just plotting the distance time graph. Hope you are understanding that how you have to plot the distance time graph. As again I am just repeating that. First of all, just take a graph. On that select the axis y and axis x. On axis y take the distance and on axis x take the time. Now mark the value that 1 centimeter is equal to what will be according to the question we are using to mark it. Okay, it will be 1 centimeter is equal to 5 kilometer also, it may be 1 centimeter is equal to 1 kilometer also, depending upon the questions. So first mark the value on x axis, 1 centimeter is equal to this, and on y axis 1 centimeter is equal to this much r. Clear? Now then you have to just mark the value. You have just made the scale. Now you have to mark the value which is always given in the question. Then draw a parallel line like this and mark the point of intersection and join the line. You will be getting a plot of distance time. Clear? Now the next thing is that types of the distance time graph. Basically when we used to plot a graph between distance and time, we always we may be getting the three types of graph. Okay, it may be when you show the graph, it may be in a straight line, in a curved line, or a line parallel to x-axis. There will be three possibilities. The first one will be we are getting the graph in the straight line, we are getting the graph in the curved line, or we are getting the graph just line parallel to time axis. Clear? So what are the results we can draw on the basis of this? When we get a line which is just straight, it always indicates that the vehicle is moving with the constant speed. Okay, again I'm repeating, if we are getting the straight line on the distance time graph, it is representing that vehicle is moving with the constant speed or uniform speed. I have explained already that what is uniform and non-uniform speed. Clear? So I don't think that here will be confusion about that. So the point is, the first point, if the distance time graph is obtaining as a straight line, it is indicating that it is a vehicle is moving with the constant speed. Now if we are getting the curve on distance time graph, as you can see here, this is the curve graph. So if we are getting the curve, it always indicates that vehicle is moving with the non-uniform motion, or you can say that it is increasing the speed. Clear? If we are getting the curve like this, we can say that it is decreasing the speed, and if we are getting the curve like this, we can say that it is increasing the speed. So first type, second type, now third type, the graph we obtain in which we are getting a line parallel to x-axis or parallel to time axis, we can say that. This the kind of graph indicates that object or the vehicle is always in rest, because here time is not changing. Okay, and if time is not changing, we cannot say that object is moving. It means that object is in rest position. So we can get the three types of the curve on distance time graph: straight line, curved line, and a line parallel to x-axis. The straight line indicates the constant speed or uniform speed. The curved line indicates the increasing or decreasing speed or non-uniform speed, and the parallel line indicates that vehicle is on rest position. Clear? Now here again the same thing is repeated. The curved line shows that object is accelerating or decelerating, and a steeper on gets faster, the object is moving. Clear? Now the same thing again, here I have told you that if the object is on stationary position, it always gives the graph parallel to x-axis or time axis. In this graph you can easily see that the distance is given here 10. Okay, at the 10, suppose that it is in kilometer, here it is given in meter. Okay, at the 10 meter, the first second it is on the 10 meter, second is it is all the 10 meter, third second it is on the 10 meter, fourth second it is on the 10 meter. It means that it is not changing its place, it is always just resting at 10 meter. It means that object is just a stationary phase or resting phase. Clear? Now find the speeds on distance time graph. How do we find the speeds on distance time graph? Here the formula is given for finding the distance of speed with the distance time graph. As we all know that the formula of finding the speed is distance upon time. So when we are going to find the speed from a graph, we used to see, as we all know that distance is shown on the y axis and time is shown on the x-axis. So we can write here x-axis upon y-axis. Whatever we are getting the points on the speed is equal to y-axis upon x-axis. Clear? Whatever the value we are getting on the y-axis, we will put on here, and whatever the value we are getting on the x-axis, we will put on here. We will get a slope, and this slope always indicates the speed of the vehicle. Clear? Now here the problem is given on the basis of the distance time graph. You have to just plot the distance time graph on the basis of the given data. Here the data is given, so let's plot a graph. Clear? This is just a simple form of graph, if you have seen. So we can see that it is just y-axis. On y-axis we used to take distance, and this is x-axis on which we used to take time. Clear? Now the second thing what you have to do, you have to just make the scale. So here we can see that 20 meter, 40 meter, 60 meter, so 20 minute, 40 minute, 60 minute, and 80 minute is given. So we can write here 1 centimeter is equal to 20 minute. Clear? As we all know that this is 0, so we will write here 20, 40, 60, and then 80. Okay, Again here on the, if we are just measuring the scale, this is on x-axis. If we are talking about on y-axis, we can write 1 centimeter is equal to 1 2 3 4 it is given, so we can write here 1 kilometer. Okay, 1 2 3 4 5 like this. Now we have just marked the scale, also we have put the value. Now we have to just put the value and draw a line of intersection. So first of all, we just come to know that at 20 minutes the distance is 1 kilometer. This is the 20 and this is 1. We will just put a dot here with a pencil, you can put. Now at the second kilometer it is 40 minutes. So second kilometer it reaches to 40 minutes. So 40 minutes it is 40. We will increase up to second. Now this is second. Now the third one is 3 kilometer at 60. 3 kilometer at 60. We will mark it like this. And 4 kilometer at 80. This is the 80 and this is 4. We will mark the value. Now we have got 1 2 3 points of intersection. We have to just make a line which is just matching with all the points of intersection. In this way we get a straight line graph. And as you all know that if we are getting a straight line graph on the distance time graph, it is always indicating that the object or the vehicle is moving with the uniform speed or constant speed. So you can also see here in 20 minutes it can move 1 kilometer, in 40 minutes it can move 2 kilometer. Mean each 20 minutes it is just traveling 1 kilometer. So it is obvious that it is moving with the uniform speed, and this is also proved by the plotting a graph after putting these all values. So this is all about today's lecture. Hope you understood all the things. Just in the next lecture we will solve the book exercises whatever is given in your textbook. Till then, have a good day and thank you.